Hello class, today we are going to start talking about two-column proofs. We are getting into the actual formal proofs, proving that this is the same that, or proving whatever statement it is they want us to prove. Remember, we're going to do this with deductive reasoning. That means every single statement that we make must be backed up by a postulate, a theorem, a rule, definition, something. Okay, we can never just say, oh, well, it looks right. Okay, we have to just have an actual definition or something to back it up. All right. Now, a two-column proof, what we do there is this is just a way of formatting it. It's just a way to organize our thoughts, is all this is. Okay, so for example, we are given that angle 1 is congruent to angle 2 in this diagram right here. And a lot of times when you have geometric proofs, you're going to have a diagram to look at. Sometimes you'll have to draw one, but usually you have a diagram given to you. All right. We know that angle 1 is congruent to angle 2. We want to prove that angle 2 is congruent to angle 1. And you may say, well, that's pretty obvious stuff. Of course it is. But we have to prove it. Everything has to be proven. Okay? So, the way we do a two-column proof is we set it up. We have two columns, obviously, hence the name. And our first one is going to have our statements over on the left, reasons on the right. Okay? And your statements, your very first statement is going to be given to you. All right? So notice we were given angle 1 is congruent to angle 2. And so first thing we write down is angle 1 is congruent to angle 2. How do you know? Prove it. Back it up. Well, we were given that information. That's how we know that that is true. All right. So we have our statements here, our reasons backing up the statements over the other side. Also, very important to number your statements and your reasons, especially when you get into bigger things. Your statements or your reasons, either one might be 2 lines, numbering them. Numbering helps. Also, you may have in really long proofs. Say, okay, statement number 5, this is coming because statement number 2 and statement number 4. All right, and so you might want that to help back things up and show how you show the flow of your thoughts and how things are working. All right. Okay. So we have that these two are congruent. Well, what does it mean if two angles are congruent? Well, it means the angles measure are the same. All right. How do I know the measure are the same? Because that is the definition of congruent angles. So you see they backed this up with a reason. All right. Well, now I want to have 2 go first and 1 go second, so let's flip those over, and we can do that. Measure of angle 2 equals the measure of angle 1 because of the symmetric property of equality, which we talked about in the previous video. Right? It says that if you're talking about numbers, measurements, lengths, something like that, then we can switch the order, and it's okay. All right? And now that I've switched the order of the measurements, I can say, hey, these two angles are congruent because that's the definition of congruent angles. Okay, if you'll notice over here in my reasons, the word prove never shows up. All right, we have given, yeah, but prove will never be down here. Okay, you can't just say prove this and this statement is right because I proved it right and it's right. That's like saying that the sky is blue because I said the sky is blue, and that proves that the sky is blue because I said so. No, you can never put the word prove in your proof. If you have the word prove in your proof is wrong. Okay? And so you did all that work above it for nothing. So you have to have a definition or a reason, something here that backs up that statement. Okay? Some kind of postulate or theorem or definition, property, something. Okay? All right. And what this is, what we have just proven, is the symmetric property of angle congruence. And so we do have a couple other properties that we want to talk about, other things that we can use for our proofs, some more tools, stick in our toolbox as it were. All right. Properties of segment congruent, properties of angle congruence. If you notice, they're the same thing, reflexive, symmetric, and transitive, which is the same thing we talked about in the previous video with equality, right? We had the reflexive property of equality, symmetric property of equality, transitive property of equality. Here we're having the same things for segment congruence and angle congruence. All right. So reflexive was saying that segment AB is congruent to segment AB, or angle A is congruent to angle A. It's congruent to itself. That's reflexive. You are the same shape as your reflection. All right. Symmetric says if segment segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Angle A is congruent to angle B is congruent to angle A. All this is doing is switching the order around, and over here we have proven that this works. Based on other properties, other things that we know are true, we have proven that angle congruence works. We could do the same thing for segment congruence. All right, it would look almost exactly the same. And then the transitive property. If segment EB is congruent to segment CD, and CD is congruent to EF, then AB is congruent to EF. I'm going to color code this because it makes things nicer. So, got the wrong end of that. There we go. Segment AB is congruent to segment CD. CD is congruent to EF. Then I can get rid of that middle part and just say AB is congruent to EF. All right. If, and we have the same thing down here with angles. Angle A is congruent to angle B is congruent to angle C, and therefore A is congruent to C. All right. And basically what you have here, the same thing as transitive property of equality. If you have two shapes congruent to the same shape, and those two shapes are congruent to each other. All right, that's what this is. And we'll use that a lot. We'll use all of these a lot, mostly reflexive and transitive. If you'll notice, though, one of the properties of equality that is not on here is the property of the substitution property of equality. You can substitute in numbers, you cannot substitute in shapes. All right, only numbers. Okay, so there is some properties, basic how two-column proofs work. Let's look at some examples. All right. So first example, there we go. Given that M is the midpoint of segment AB, we want to prove that the length of AB equals 2 times the length of AM, and that AM is half the length of AB. All right. So first, they've already given us the statement, so that's nice. We just got to back it up with reasons. Okay. M is the midpoint of segment AB. How do we know that this is true? Well, because they told us it was true. It was given to us. So we're going to have some given information. All right. This is the given information right here, is right there. And you're almost always going to start with what was given to you. Okay. Everything else we've got to come up with on our own, but you're always going to start with what you're given. All right. So based on that fact, based on the fact that M is the midpoint of segment AB, they are telling us that segment AM is congruent to segment MB. Right? How do we know this statement is true? Well, this is the definition of a midpoint. Right? The definition of a midpoint is it is a point that divides a segment into two congruent segments. And so that's what this is. It makes those two are congruent segments now. So based on this statement, they're going to make the next statement. The length of AM equals the length of MB. Notice we are now talking about the measurement, and so instead of having congruent, we have equal to. Right? Because numbers are equal, shapes are congruent. So if the shapes are congruent, the segments are congruent, how do we know that they have the same length? What backs us up? Why can we say that? That is the definition of congruent segments. And I'm going to abbreviate here. All right. So now I know that those are congruent. Why did we want to talk about the measurements? Well, because that's what we have to prove. We have to prove things about the measurements, so we need to get it to where we're talking about the measurements. All right. Okay, so next we have that the length of AM plus the length of MB equals the length of AB. So this piece plus the length of that piece equals the length of the whole thing. How do we know that's true? Well, we have two segments right next to each other, and so we can add them up, and that is the segment addition postulate. So that's what we write down here. All right, segment addition postulate. So what do we do going from this line to that line? Let's see, we have AM plus AM equals AB. What changed? Well, MB switched to AM, right? We switched which segment we're doing. How can we do that? What lets us do that? Well, let's see here. Okay, here we go. AM is the same thing as MB, right? And so if AM is the same length as MB, they have the same measurement, they equal each other, That means anywhere I have MB, I can take the MB out and put the AM in, right? And so this is called substitution property of equality. So that's what we're going to put here. We're taking this out and putting that in. We're substituting. All right, substitution property of equality. So next line, they have 2AM equals AB. So we had AM plus AM, and we're just combining that to say 2AM, which is what we're looking to find, right? 2 times the length of AM equals AB. 2 times the length of AM equals AB. That's what we were asked to prove. Notice I am not going to write the word prove down here. What I'm going to write is that I'm taking AM plus AM and calling it 2AM. This is just combining like terms. That's all it is. Combining like terms. You could also call this simplifying, right? That's all it is. We just simplify that side. There it is. Now we are asked to find another thing. We are asked to show that the length of AM equals 1/2 the length of AB, right? And so how can I get from 2AM equals AB to AM equals 1/2 AB? Well, yeah, that's all we did. We divided by 2, or since this has 1/2 times AB instead of AB divided by 2, instead we'll say we multiplied by 1/2, right? Multiply both sides by 1/2, and we're good. This is the multiplication property of equality. Okay, multiplication property of equality. And that is, I have proven these two statements, but notice nowhere in here did I use the word prove, right? I backed it up with another reason. Okay. All right, so there's one. It wasn't too bad. Wasn't too bad. Let's take a look at another one. Remember, what we have to do here, we're using deductive reasoning, so every statement that we use has to be backed up by a reason, by a definition. Okay, so what do we have on this one? We have segment AB and segment CD bisect each other at point M. So let's see, AB and CD bisect each other at point M. And we are also told that segment BM is congruent to segment CM. Okay, so these two bisect each other, these two are congruent, and we want to prove that the length of AB is equal to the length of AM plus the length of DM. Okay, so let's see, AB would be AM plus MB, but we want to say AM plus DM. Okay, so let's see. Again, they've already given us some of it. They've given us most of the reasons and most of the statements and asking us for reasons, but they did ask us about one statement there. Okay, so let's see here. Starts off with segment AB and segment CD bisect each other at point M, and they even gave us the reason for that. The reason is given. It is up here in the given. But if we have some more stuff here, we also have that we're given that segment BM is congruent to segment CM, so that also needs to be stated, right? And so all of this here, we're just going to take that whole thing and stick it down in here. We put some of it in statement 1 and the rest of it in statement 2, so this is also going to be given to us. All right, all of this here, just copying it straight off of the original statement. Now, everything else we've got to come up with. So based on the facts that we've already stated, they were saying that the segment CM is congruent to segment DM. How do we know that? Do we know that from statement 2 or statement 1? We know it from statement 1 because CM is here, DM is there. M is where they bisect each other. That means M is the midpoint. All right, so basically this is the definition of a segment bisector, is just like the definition of a midpoint. Now know that these two are congruent to each other. What else do we have here? Segment BM is congruent to segment DM. How do we know that BM is congruent to C? They're not on the same line, right? They're on different lines, so I can't say segment bisector for that. But we do know that BM is congruent to CM, CM is congruent to DM. So we have both of these are congruent to the same segment, right? So that's right over here, two segments congruent to the same segment, means those two segments are congruent to each other. This is the transitive property of segment congruence. It's transitive property of segment congruence. Trying not to remember that at the end. Okay, but I'm not asked about the segments, I'm asked about the measurements of the segments. So let's change these to measurements, right? So the length of BM equals the length of DM. So these two have the same length. How do we know they have the same length? Well, same thing we said up here when we wanted to say they have the same length. All right? The segments are congruent, so they have the same length. This is definition of congruent segments. Definition of congruent segments. Okay, now the next one they didn't give us, did they? So let's see, we're going to have to put this together. Let's see, they said we're going to use segment addition postulate. So segment addition postulate is where you take two segments that are end to end and you add them together, right? And we're trying to prove the length of AB. So let's take a look at that. So AB would be the length of AM plus the length of MB. That's what we can do there, because that's what we're trying to prove is AB. So we'll use AB. So over here, I will put that the length of AB equals the length of AM plus the length of MB, because segment addition postulate says I can do that. But we want the segment of AM plus DM, so we want to change this MB to DM, right? How can we do that? Well, we can do that because those two equal each other, right? The length of BM, the length of DM is the same thing, so I can interchange them. So I can take the MB out, put the DM in, and that is because what statement down here? Yeah, substitution, right? Two things equal each other, you can substitute one for. There it is, substitution property. Remember, substitution only works for measurements. Only works for measurements. Numbers, angles, the degrees of the angles, lengths of the segments. Again, I didn't use the word prove. Don't do that. So there it is. You have statements, reasons to back up your statements step by step by step by step by step. Okay? Always have a definition or a postulate. All right? So there it is. Hopefully this is starting to make some sense. All right, so here are a couple more examples of proofs. All right. So in this first one, we are given that angle AEB is a complement of angle BEC. And we are asked to prove, so let's see here, where is that? AEB is complementary to BEC. So these two angles are complementary. We are asked to prove that the measure of angle AED, so this angle here, is 90 degrees. Okay? Now this one, again, they've given us some of the information, and we're asked to fill in the others. Some of it we're doing statements, some of it we're doing reasons, a little bit back and forth there. All right, so the first one, again, we are always starting off with this given statement. All right, given statement is always where we start off. Angle AEB is a complement of angle BEC. Always start with that. Whatever it is was given to you, you got to start somewhere. That's where we're starting. All right. So next, okay, they didn't give us the statement, but what they did say is we're going to use the definition of complementary angles. So what is the definition of complementary angles? Because we got to use what we started with. All right, that's all we have. Complementary angles. So we got to start there. Complementary angles, if you remember, are two angles that add up to 90 degrees. So that's what we're going to say. We're going to say that the measure of these two angles is 90 degrees. Measure of. All right, so the measure of angle AEB plus the measure of angle BEC equals 90 degrees because they are complementary angles. Definition. Okay, so the next thing they say is the measure of angle AEC plus the measure of angle, AEC, so this whole big thing, those two angles added up, plus the measure of angle AEB, let's see, AEC and AEB is BEC. Oh, I'm reading it backwards. The measure of angle AEC, the whole big thing, equals those two angles added up, right? There we go. What is it that says you're going to add two adjacent angles to each other? Angle addition postulate. Well, segment addition postulate we were using a minute ago, right? So this is the angle postulate. Angle addition postulate. And now they're telling us that the measure of angle AEC, this big angle there, is 90 degrees. Well, how did we get from saying that AEC was these two angles added up to saying that no, it's 90 degrees? Well, what we did, if you'll notice, we have the measure of angle AEB plus the measure of angle BEC. And down here we have the measure of angle AEB plus the measure of angle BEC. So again, I have this stuff equals 90 and this stuff equals the measure of angle AEC, so I have both of those equals the measure of AEB plus the measure of BEC. So if I have two things that equal a third thing, then we can use the transitive property. If they both equal a third thing, they must equal each other. This is the... Now, honestly, on this one, there is another thing you could have used instead. You could have used substitution, would also have worked here. You're taking this stuff out and we're substituting the 90 in. Also works. Okay. Transitive and substitution, there's times when you could use one or the other. All right. Okay, so now we have that the measure of angle AEC is 90 degrees. And then we're saying, hey, you know what? The measure of angle AED plus AEC is 180 degrees. How do we know this? Well, we know this because they're supplementary. How do we know this? Because they make a straight line, right? Those two angles are a linear pair, which means they're substituted. And really, this should have another line in there, in between those two, saying that the measure of angle, that AED and AEC are a linear pair. All right. So, because they're a linear pair, we know that they add up to 180 degrees because linear pairs are supplementary. All right. So now we have that those are that, and we want to change it using substitution property, apparently. So we're going to take something out and substitute something else in. Well, the only thing on this statement that we have that we could know another value for is AEC, because the measure of AEC is 90 degrees, so that means I can take this out and put the 90 degrees in. So that's what I'm going to do. So the measure of angle AED plus 90 degrees equals 180 degrees, because AEC is 90, so I can take that out and put the 90 in. Substitution property. Take one thing out, put something else in. Okay, so now what can I do with that? Well, now I can get from there to my final statement saying that the measure of angle AED is 90 degrees. How? How do I get from this statement to that statement? Yeah, all we got to do is we got to subtract 90 from both sides, and 180 minus 90 is 90. That's what we're going to do. We're going to subtract. So this is the subtraction property of equality. Subtraction property of equality. I can subtract 90 from both sides of the equation, and I end up with the measure of angle AED equals 90 degrees. All right. So again, you'll notice I did not use the word prove anywhere in my statements here. Anywhere in my reasons, you do not use the word prove. All right. So again, not too bad, making a little bit more sense. And now we get this one here where they tell us nothing at all. They're not giving it any to us. We have to come up with all of it on our own. So let's take a look at this. We are given that B is the midpoint of AC. So B is the midpoint of AC. We're also told that C is the midpoint of BD. We want to prove that AB, this little piece, is the same length as CD, this little piece there. What do we start with? Well, we start with the same thing we start with every time, and that is the given information. This is what we're going to start with. Just like we do every other time, we're just going to put that down there, and we're going to put it on two lines like we did on one of those other ones on the previous video. Over here, right, we split it up into two different lines. We can do that, that's fine. So what we have here is B is the midpoint of segment AC. How do I know that's true? It was given to me. And then the other one, C is the midpoint of segment BD. How do I know this is true? I know this is true because, again, it's given to me. Given to me. All right? So that's all they're telling us. That's it. Everything else we have to come up with all by ourselves. All right? So let's take a look at this. We need to say something. Well, all we know is it's a midpoint. So we can start with, okay, then what is a midpoint, all right? What's a midpoint? Well, a midpoint divides a segment into two congruent segments. Okay, so if B is the midpoint of AC, that means it divides it into two congruent segments. These two segments must be congruent. And if C is the midpoint of BD, then these two segments must be congruent. All right? So let's say that, because that's all we have. All we have is midpoint, so let's say that it's made congruent segments. Sure, why not? So we know that segment AB is congruent to segment BC. And you know what? We can put this all on the same thing. We also can say that segment BC is congruent to segment CD. How do we know that's true? Because B is the midpoint here, C is the midpoint there. It's definition of a midpoint. And you can put things all on the same line like this if it's for the same reason and happens at the same time. So definition of midpoint. All right. So we could have put those two on the same line as well if we wanted to, but they wouldn't have fit. So put them on two lines. These are nice and short. We stick them on the same line. It's all good. Alrighty. So what does that mean? We have congruent segments. What are we trying to prove again? Lengths. Length of this segment equals the length of that segment. So we need to say something about the lengths of the segments, right? Okay. Do we know anything about the lengths of the segment? Well, we know the segments are congruent, which means the lengths are also going to be the same. So let's say that. Let's talk about the lengths of these segments. So the length of AB is going to equal the length of BC. The length of BC is going to equal the length of CD. All right. So they equal each other. The lengths are the same. How do we know that the lengths are the same? Because they're congruent segments. And this is the definition of congruent segments. Definition of congruent segments. Right? The segments are congruent. They have the same length. There we go. That's not what we're asked to do, right? We're asked to do AB equals CD. So can we get there yet? Well, let's see. We have that AB equals the length of BC. BC equals the length of CD. So AB and CD both equal the length of BC, right? Hey, this is transitive property. Two things are equal to the third thing. Those two things must equal each other. So we can go straight to that. We don't even need that sixth line there. All right, so the length of AB equals the length of CD. How do we know? Transitive property. Transitive property of equality. Two things are equal to a third thing. If they're equal to the same thing, then those two things are equal to each other. And there it is. We have proven it step by step by step by step. We did not use the word prove. Did not use the word prove anywhere in there. And so this is how it's done. All right. So just a refresher. Two column proofs. Statements on the left. Reasons on the right. Always start with your given statement. Work down until you get the statement you're trying to prove. Do not use the word prove anywhere in your reasons. And don't forget, we do have some more properties here. Reflexive, things are congruent to themselves. Symmetric, you can change the order of your congruent statement. And transitive, if two things are congruent to the same thing, then those two things are congruent to each other. All right? Hopefully you found this useful, and I'll see you in the next video.